In the previous sections, we were looking at algebraic functions, polynomials, rational functions, those sorts of functions that we've seen a lot. And we're going to move into a new section in the course, and we're going to start talking about these sorts of exponential functions. And exponential functions are going to lead to other sorts of transcendental functions like logarithmic functions. So let's discuss what an exponential function really is. And so an exponential function is going to be any function that has this form, b to the x power. So the x is in the exponent, all right? So we've seen polynomial functions like f of x equals x squared, etc. Okay, but we haven't necessarily taken a look at what happens when we have an exponential function. So in this section, we're going to explore not just the exponential functions, but what the graphs of the exponential functions might look like. And then we're going to define something called the natural exponential function, which is going to be the e to the x, and we're going to explore the graph and the properties of that. And then finally, we're going to be able to use our rules of transformations to be able to shift the graphs. Okay, so exponent is comprised of two parts, a base and an exponent, which we've seen many times. And exponential functions have a horizontal asymptote at the function y equals 0. And what's going to happen is that the function is going to approach 0 as x goes towards negative infinity. Right? Now, as x approaches positive infinity, what's going to happen is that the y value will also approach infinity for this form of the function, okay, if b is greater than 0. Okay, so the first thing we're going to do is we are going to graph a few of these exponential functions just to take a look at what they look like. We're certainly going to verify what the graphs look like by using some sort of technology. So let's graph this function, f of x equals 2 to the x, and let's give the domain and the range and interval notation. And then we're also going to take a look at what the equation of the asymptote might be. All right, so first thing we're going to do, I always start from the positive numbers and I just work my way down to the negative numbers, just because positive numbers are easier to deal with. So remember, our function f of x is 2 to the x, and so f at 3 is going to be equal to 2 cubed, which is 2 times 2 times 2, which is going to be 8. Okay, so we have the coordinate 3 comma 8. All right, so I'll plot all these once we're done figuring out what the table of values is. All right, next thing we're going to figure out is f at 2. So f at 2 is 2 squared, which is 4. And then f at 1 is going to be 2 to the first, which is 2. Now, this is where students start to get a little tripped up with this. F at 0 is 2 to the 0. That is not 0. Okay. Any number except for 0 raised to the 0 power is going to be 1. Okay. So any real number raised to the 0 power is going to be 1. All right. And then 2 to the negative 1. So f at negative 1 is going to be 2 to the minus 1. And that is not equal to negative 2. Okay, a lot of students will say this is negative 2, but that is not correct. All right, it's actually going to be 1/2. All right, and let me illustrate why it's 1/2. All right, so that's not equal to negative 2. What it actually is going to be equal to is a half, because anytime you have a negative exponent, what that means is that you're going to flip the fraction over. So you're just going to take the reciprocal, and then you're going to make the exponent positive in the denominator. All right, and that's just going to be 1/2. All right, and then if we had f at negative 2, that's going to be 2 to the minus 2, which is 1 over 2 squared, which is going to be 1/4. And then finally, f at negative 3 is going to be 2 to the minus 3, which is going to be 1 over 2 cubed, which is 1/8. All right, so now that we have these points, let's go ahead and plot them. And I'm going to zoom in just a little bit just because the 1/8 and the 1/4 and the 1/2. So we have negative 3, 1/8, which is just about going to be on the axis. And then negative 2, 1/4, which is just a little higher. And then negative 1, 1/2. And then we get 0, 1. All right, so just imagine that point. Don't know how that happened with the line. It's okay. And then we have 1, 2. And then we have 2, 4. All right, and then finally we have 3, 8, which is up here. Now, notice that the exponential function raises up pretty quickly. All right, so our function is going to look something like this, or the graph of the function. And the other way, it's going to get closer and closer. I know that's not a good graph of this, but as you can imagine, this is going to get closer to the x-axis. All right, let me try one more time. And if that doesn't work, then I'm just going to quit. Let me see if I can go this way. Maybe that'll work a little better. Nope. Really tough, unfortunately, to draw on the computer screen. So apologies. Let's try one last time. Yeah, here. All right. So now this goes this way forever towards negative infinity. All right. And so if I was to define the domain of this, okay, so the domain is going to be all real numbers. Okay, so negative infinity to positive infinity. The range, now notice that it's trending towards zero, but it never for the y value, but it never dips below the x-axis. Okay, and so the range is going to be from 0 to infinity, right? And then there's an imaginary line that this is approaching when y is equal to 0. All right, now last thing we're going to do is let's go ahead and just take a look at what the graph looks like. We can go into our graphing calculator and let's just remember a few of these points. All right, because that way we can go ahead and graph it. And so I have the function y equals 2 to the x. All right, and then a few of the points just to verify. We had the point 1 comma 2. All right, so that's certainly on there. We had the point negative 3 1/8, I believe. And I'm going to label these. So that certainly makes sense. And then I'm also going to plot the asymptote y equals 0, okay, which is going to be the axis. And so at least this is a way for us to verify that this makes sense, right? One of the most important points that we're going to look at is the point 0, 1, all right? And that's going to be stationary, all right? And the reason I'm going to use this point is because almost every exponential function, unless it's transformed, is going to have like this point on here. So we can just move a couple of these points when we do the transformations. Right. So that's just a really basic overview of a pretty simplistic exponential function. Now we are going to graph a few more of these, and we're also going to graph the transformations in subsequent videos. But for now, this is just an introduction as to what an exponential function is and what an exponential function's graph looks like.